as this is also known as freezing point or ice point. This is also known as freezing point or ice point. This is also known as freezing point or ice point. This is also known as freezing point or what? Ice point. Full stop. It is a temperature. It is the temperature. It is the temperature. It is the temperature. It is the temperature at which water freezes for that given scale. It is the temperature at which water freezes for that given scale. It is the temperature at which water freezes for that given scale. For that given scale. Let me ask you guys, at what temperature range or temperature does water behave anomalously? Between 0 to what? 4. Between 0 to 4 degrees. Now, what do we mean by water is anomalous? I know it's abnormal. What does it mean? What does it mean? What does it mean? When water is heated, it does what? Contracts. But what? But what? But expands on what? Boiling, heating. But is that what I taught you? What did I teach you? What did I teach you? What did I teach you? In answer notes. You're opening notes. It's a new week. You came to learn fresh things. Old things are passed away. Behold, all things are new. Abi? In answer me yes. You're telling no. You're telling me yes. Hey, don't worry. When life will hit you, you will know. I told you that water behaves anomalously when it is heated or cooled between 0 to 4 degrees Celsius. And that anomalous behavior means that water expands on cooling. Expands on cooling, but contracts on what now? Heating. And I gave you several examples. I was even talking about Pepsi, Coke, and what. But you will still forget. You will still forget. I bet, where did we stop? Anyway, what did we say, Bigo? For that given scale. Full stop. Example. For the Celsius scale, it is 0 degrees Celsius. It is 0 degrees Celsius. For the Celsius scale, it is 0 degrees Celsius, comma. For the Fahrenheit scale, it is 32 degrees Fahrenheit. It is 32 degrees Fahrenheit. It is 32 degrees Fahrenheit. And for the Kelvin scale, it is 273 Kelvin. Don't put degrees. Oh, it is 273 Kelvin. It is 273 Kelvin. Full stop. It is 273 Kelvin. Full stop. Pick up the next one. Upper fixed points. Upper fixed points. Upper fixed points. Upper fixed points. This is also known as steam points. This is also known as steam points. Steam. What is steam in Igbo? What? Unzo. Unzo. Uzwo. Nzu. Nzuku. Uzuako. What of smoke? Anwuru. Anwuruoko. Okay. Then steam is uzu. Uzu. Abi? Uzu. Uzu. Hey, nine. Hey, who I go follow? Who I go follow? Uzu, Uzu, Uzu. Which one? Okay. We said it's also known as what? I'm waiting for you. Is it you? Oborogwa. Okay, is this guy? Okay. Okay. So we said it is also known as what? Steam point. Sorry, steam what? Steam points now. They are steam points. It's also known as steam points or boiling points. Or boiling points. Are we there? Full stop. It is the boiling point of water for that given scale. It is the boiling point of water for that given scale. It is the boiling point of water for that given scale. It is the boiling point of water for that given scale. And see, it is the boiling point of water for that given scale. It is the boiling point of water for that given scale. Full stop. Example. 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 For the Celsius scale, it is 100 degrees C. For the Celsius scale, it is 100 degrees C. For the Celsius scale, it is 100 degrees C. Hello? Why are you not writing? Hello, beautiful. Why are you not writing? Yeah? Are you tired? Make sure you're writing. This side. Yeah, you can stay on the other seats there if you want to. But just this side. Okay, so for the Celsius scale, it is 100 degrees Celsius, comma. For the Fahrenheit scale, it is 212 degrees Fahrenheit. Degrees F. For the Fahrenheit scale, it is 212 degrees F. For the Fahrenheit scale, it is 212 degrees F. And for the Kelvin scale, it is 373 Kelvin. And for the Fahrenheit, for the Kelvin scale, it is 373 K. It is 373 K. Full stop. Full stop. In summary, comma, thermometers are represented as shown below. In summary, comma, thermometers are represented as shown below. 0 degrees, 100 degrees, C. So this is Celsius scale. Then we have another one. This is 32 degrees F. This is 212 degrees F. This one is Fahrenheit scale. And then we have the last one, but not the least, 273K. And then we have 373K. So here is the Kelvin scale. Is anybody here Kelvin? Any Kelvin here? No Kelvin. Okay. Anybody Celsius? Anybody who's called Celsius? Okay. Yeah? Your name is what? Your name is Celsius. Your own is Fahrenheit. Okay. Adema. Are we lady? You're not lady. What are you? Okay, you're not lady. No problem. I hope you ate lice on Sunday. You not eat lice on Sunday. Or you ate blood. Did you eat blood this morning? Did you eat blood this morning? You ate blood this morning, right? Okay. You know, some people have damaged tongue. Yeah, is that if you can't say bread or rice, it's totally damaged. Okay. Students was talking to me the other time. Mr. Prime, Mr. Prime, do you want to eat lice? I was like, no. I was like, no, no, I don't want to eat lice, please. I don't want to eat. Uh, uh, he was like, no, now, why not? Why? I was like, no, I'm not hungry. No, you can't be hungry for that case. Okay, now let's explain what we said so far. So we said that when you see a thermometer, there are two important temperatures for any thermometer. There are two important temperatures for any thermometer you're going to see out there. So whether it is a Celsius thermometer, a Kelvin thermometer, or a Fahrenheit thermometer, there are two important temperatures that you should always look out for. And the truth is this, pay attention. Apart from this, and this, anybody can also come up with their own thermometer. Okay? Now, but when they come up with their own thermometer, there are two important questions that we ask them. What is the lower fixed point of that thermometer? And what is the upper fixed point of that thermometer? For those of you that are going to write WAEC will say, define the following. That is question 8, 2026 WAEC. Number 8, AI. Yes. Define the following. Then you have lower fixed points. You have upper fixed point of a thermometer. You will now tell them that lower fixed point is the temperature at which water will do what? Freeze for that given thermometer. The temperature at which water will freeze for that given what? Thermometer. Another name for lower fixed point, but freezing point or ice points. Good. So because sometimes WAEC might remove it and put ice points. Okay? So just know that it is interchangeable. Either lower fixed point or ice point or boiling point. Sorry, or what? Freezing point. Good. So when we say lower fixed point, we mean the temperature at which water will freeze for that given scale. Then when we say upper fixed point is the temperature at which water will what? Boil. So upper is boil. Lower is what? Freeze. Good. So upper fixed point is the temperature. I even know book. Did you go to back of school? That kind of thing. But the person is actually correct. You are the one that went to back of school. Okay? So what you should ask the person at that point is, what scale are you talking about? The person will now say, okay, I'm talking about the Kelvin scale. So, because... Hey! Wait! Is that how I sound online? Oh my God. Oh my God. Really? Oh my God. Don't worry, I will change career. I will now become Sabinus, right? Become Sabinus, yeah, because that kind of sounds funny. Okay, so if we talk about boiling point of water, we can also say that water boils at 373 Kelvin. We can also say that water boils at 373 Kelvin because 373 is the upper fixed point for the Kelvin what now? Scale. Is that making any sense? Good. So that is exactly what we are referring to. Now, we also talked about lower fixed points. So lower fixed points for the Celsius scale is 0 degrees Celsius, meaning that the freezing point of water is 0 degrees. But somebody can also say 32 degrees Fahrenheit. Now, the only difference is that this one is using a different scale. This one is using a different scale. Is that okay? Keep those chairs. Go and keep it. Keep the chairs. Put it back. Yes, there are spaces here. Are you not seeing empty seats? There are empty seats here. Go and keep that seat and see. There are empty seats here. All these things are empty seats. Okay. Then, so for the Fahrenheit scale, water will freeze at 32 degrees Fahrenheit. Then 273 Kelvin for the Kelvin scale. Is that making any sense? Is that making any sense? Good. Now we're going to be using this thing. These things are very, very important. Okay? You are going to see how important they are. Write down calibration of thermometers. Calibration of thermometers. Calibration of thermometers. Calibration des thermomètres. Calibration of thermometers. Are you ready? Okay. Now, right. Can be calibrated using standardized or good thermometers. No noise. Let's say you have a faulty thermometer. That faulty thermometer is going to cause errors when you are using it. Why are you laughing now? So, as I was saying, if you have a faulty thermometer can bring about errors. It can bring about errors, especially in critical cases. In the hospital, for example, they use thermometers. What do they use thermometers for in the hospital? To check what? Temperature of who? Of human beings, right? Good. Now, do you know that in fact, as a human being, let's assume that the nurse or the doctor or whoever used a faulty thermometer. They don't know that the thermometer was faulty. And then they use that thermometer to measure your temperature. And it gives them a wrong value. That wrong value can mean a wrong diagnosis. Do you know that? Good. So normally, a human temperature, if you are okay, should be between 36.6 to 37.2. I think 37.2, Abi, 37.6, I can't remember. But on average, it's 37, Abi. Good. This is how your temperature should be. If you are okay, you are normal, nothing is happening to you. But imagine the nurse used a faulty thermometer. And then when they used that faulty thermometer, the thermometer was now giving them, let's say, 41 or 42. Now, in your head, you will be like, 37 is supposed to be normal. But if the thermometer is giving me like 42, there's nothing much. There's no much difference. What is the difference? 42 minus 37 is, I mean, like 5. Abi? It will be like 5. You'll be like, it's not much, right? In health, it is much. In health, it is what? Much. In fact, if your temperature as a normal human being, if your temperature rises to 41, not even 42, 41, it means that you are having a critical fever. You are having critical fever. So a situation where you are okay, you are looking normal, nothing is happening to you, and then they now check your temperature, and the temperature was given 41. They will know that there is a problem. It is a very, very big problem. You might say, don't worry, I'm okay, nothing is happening to me. But it will be a very big problem. So what the nurse or what that doctor would do is that they will try to maybe check using another thermometer. They will check using a different thermometer. And if another thermometer is giving them the same results, they will now, tell you to just sit down. And then they will start giving you, what is it called? They will start, what do you call that? Auntie, keep the chair. Keep it. Come and sit here. There's space here. Okay? They will now quarantine you. Okay? Because at that point, you are no longer normal. Because it is a viral or a virus that can cause your temperature to spike like this without you feeling any way. Okay? You'll be normal. Normal. Okay? And then their temperature is at 41. The person is not normal. The person is probably infected by a virus. And at that point, they should do what? Quarantine you. Put you in one room. Keep only you there and be running tests to know whether the virus can be transmitted or not. Okay? That is why during Ebola, were you alive during Ebola? Were you alive? Ebola was in 2014. 2014 was how many years ago? Like 11 years ago, right? 11 years ago. Where were you 11 years ago? Primary school. Primary Guinea, primary what were you? Primary 6. You primary 6. If I throw my hand from here. Okay? So, you are what? Not a 3. Yeah, it fits you. Not a 3 fits you. Okay? Now, during Ebola, if you go to the bank or you go to any gathering, what happens? They normally check temperatures. They will check your temperature, and the temperature they are using, the thermometer they are using, is not the one that will have contact with you. It's the one that they will stand at a distance and point it as a gun. Have you seen that thermometer before? So the one that they I'll bring t-shirt. Are you an Arsenal fan? Who do you know in Arsenal? Okay, so that's how it is. So that one that will be like gun, they will point it at you, because the person that is even checking the temperature is at risk of you infecting the person. Not only that, even during COVID, where were you during COVID? You were at home, right? You didn't go anywhere for how many months? 9 which months? You going to? You had somewhere to go. So government said, stay at home. You used to go out. It's between you and where you are going to. Okay, like if someone touches you, you need joy, but internally your temperature is spiking. Very important. Thermometer, how would you prove? Okay. I mean, good thermometer to fix a bad one. Are you with me? We are trying to use a what? A good thermometer to do what? Fix a bad one. Okay? That is what we do. Now, let's see how that can be done. So I'm going to give you a general case. Now, this thing we are doing can also be used to convert from one form to another. Because I have seen questions in exam where they said, convert so to so. So it might be convert Celsius, maybe a temperature is 60 degrees Celsius to Fahrenheit or to Kelvin. Of course, everybody knows how to convert to Kelvin, right? From Celsius to Kelvin. What do? You add 273. Or is yoku? Good. So, we gas laws. You've not done gas laws. You've done gas laws. You've not done it. Why have you not done it? Why have you not done it? Who has not done gas law here before? Hands up. Or forever remain silent. Nobody. So everybody has done it. You see? I'm not talking about here. I'm saying you've done it before or you've come across it before. Abi? Now, you see that when you're solving questions on that gas law, let's say Charles law, that has to do with temperature, or you're using general gas law. You know general gas law, right? Good. Now, whenever they give you temperature in degrees Celsius, you have to convert it to Kelvin before you start solving. Up here? So, for example, if I tell you a temperature of 27 degrees Celsius, you will convert it to Kelvin. How do you convert this guy to Kelvin? You add 273. When you add 273, this should give you what? 300 Kelvin. Then this is what you will now use for that calculation. Are we here? Have you ever done that before? Good. Now, but of course, we can use this general process that I want to show you now to convert between temperatures. Now, let's see. Let's imagine that you have two thermometers. Okay? So this is how we represent thermometers. Okay? Now, I'm going to call this, let me just call this bad thermometer. This is the bad thermometer. Okay? This is the bad thermometer. And like I was saying, it doesn't have to be bad thermometer. It can still be this one can still be Celsius thermometer, and this one can still be Fahrenheit thermometer. I'm just using bad and good thermometer here because we are trying to do calibration. Okay, so this is the bad thermometer and this is the good thermometer. So this is what we have. Now, I told you that thermometers have two important temperatures. What are those two important temperatures? Lower fixed point and upper fixed point. No problem. Now, so the bad thermometer, we have a lower fixed point here, and the bad thermometer will have an upper fixed point here. So let's assume that the lower fixed point here is A. I don't want to put a value. Because in questions the values can be altered. Is that okay? Good. So A is the lower fixed point here, and then let's say B is the upper fixed point here. Now, the good thermometer, we also have lower and upper. Now, X, Y. So class, if I ask you, what is the upper fixed point of the bad thermometer? What is the upper fixed point of the good thermometer? Y. What is the lower fixed point of the good thermometer? X. What is the lower fixed point here? A. Is that making any sense? Good. So meaning that if you are comparing, if you are doing comparison, A is equivalent to X. B is equivalent to what now? Y. Because Y and B are upper. Nkabo lower. Are we here? Good. Now, what we want to now do is we want to compare C to Z. We already know that X corresponds to A, Y corresponds to B. Therefore, C will also correspond to what now? Z. Meaning that, let's assume that C is an arbitrary temperature. Meaning, it's a temperature we are trying to know whether it is good or not. This is the temperature we are trying to know whether it is good or not. Whether it matches the Z or not. So, we have an equation. And the equation, I simplified it to look like this. Whenever you want to do anything like that, just remember this ratio. That's small interval over large interval is equal to a constant. Let me write it in full. Is equal to a constant. If you remember this, then you will know peace. That small interval divided by what now? Large interval is equal to a what? Constant. A constant means something that does not what? Change. Something that does not change. So let's look at this now. It means that I need to find small interval and large interval. Now, small interval is from here to here. Middle to bottom. Middle to bottom is small interval. Large interval is top to bottom. Are you with me, class? So in both cases, you are going to the bottom. So small interval is from middle to bottom. Larger interval is from upper to what now? Bottom. Is that making sense now? So interval means difference. So what is my small interval for this guy? It's going to be C minus A. Meaning any value that is here. In question, C is a value, C is a number, A is also a number. Is that making sense? Good. So C minus A, then that is my small interval, divided by, my large interval is what? B minus A. So B minus A. Then it is going to be equal to, now instead of putting a constant, I will do the same thing here. The same thing I did here, I will do it here and get my final equation. So what does that mean? I will say small interval. What is the small interval here? Zx. So which is what? Z minus x over what? Y minus x. And this is the formula we are trying to find. As simple as that. Now, these letters represents numbers. They represent what? Numbers. So in actual sense, it is only one letter that is unknown. Is that making any sense? So when we start solving questions, you will find out that it is only one letter here that is unknown. And if I have only one unknown, can I look for it now? I can now maybe cross multiply and then do basic algebra. Are we here? Oh yeah. Copy this and let's take examples. Copy that quickly and let's take examples. You're not better than some people who say, you know. Yeah. Are we ready now? Are we ready? Okay, let's take example 1. Example 1. Example 1. A faulty thermometer. Let's go. A faulty thermometer. A faulty thermometer. A faulty thermometer. A faulty thermometer records. And I forgot to wish you guys happy new month, right? It's a new month. Today is 1st of July. Are we here? Happy new month, everybody. Is anybody's birthday this month? Yes. If you are born in July, stand up. Stand up. July what? Please, July what? July again. 3rd. That is like next tomorrow. So I should come without eating, Abi. Hunger will strike me, Abi. Yeah. Just bring your cake, okay? There's love in sharing. Okay, I said a 40 thermometer did what? Okay, records 5 degrees Celsius at ice point. Are we there? And 105 and 105. Records what? This thermometer records 55 degrees. Idego? Good. Now, I don't believe in formulas because they fail. So, pay attention and let's see how we can solve that. Of course, you see that we'll still come back to this. But I want you to understand what is happening. Whenever you see a question like this, the first thing you do is draw the 2 thermometers. Draw the what? Draw the 2 thermometers. And that means the bad one and the good one. Okay. Oya class, let's draw the bad one first. This is the bad thermometer here. What is the synonym of it? Worse. I beg, let's continue. So this is the bad one. Now, they told us that the bad one records what? Lower fixed points, beginning 5 degrees Celsius. Oh yeah, get monte. It is recording 5 at lower fixed point. 5 degrees Celsius at lower fixed points. This is wrong. The good one should record Guinea. What should the good one record? Remember, what scale are they talking about here? Celsius. Celsius scale. A good thermometer for the Celsius scale should record what at lower fixed point? 0. 105 at what? At steam point. So 105. Is it a good thermometer or a bad one? A bad one. A good one should record what? Is that making sense now? Good. So here now, the bad one records 5 at lower fixed point instead of 0. 105 instead of 100. They are now asking us, what is the gain? Oh yeah, read it. What is the gain? Actual. Now, when they say actual, is it bad or good temperature? Good. So what is the actual temperature when the gain? When this thermometer, which one? The bad one, records gain? Good. So they are now asking us, Obona this bad one negotiate 55. Kediye buzi the normal one. Let's call it gain X. We don't know it. So we now find it. Are you with me now? So what do we use? Small interval over what? Oh yeah, what is my small interval here? 55 minus 5. Is that making sense? Are we ready? Are we men? Okay, another one. Another one. Another one. With the best music. Yeah, bad boy. Number 2. A faulty thermometer records 8 degrees C at ice point. A faulty thermometer records 8 degrees C at ice point. A faulty thermometer records 8 degrees C at ice point. 8, yes, 8. 8. 80. 8 degrees C at what? Ice point. And 90 degrees at steam 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 point. And 90 degrees at Guinea. Full stop. Full stop. Full stop. Calculate the actual temperature. Calculate the actual temperature. Calculate the actual temperature. Calculate the actual temperature. Calculate the actual temperature when this thermometer records 40 degrees Celsius. Calculate the actual temperature when this thermometer records 40 degrees Celsius. When this thermometer records 40 degrees Celsius. Can you do that? Oh yeah, help me. Help me, help me, help me. Yes, they carry me go, yeah, no. Why did you come late? Where? 4 corners. Okay. Hey, next time wake up earlier. The law. How are you? You're welcome, man. Any answers? 30. Okay, 39 degrees Celsius. That's good. 39. You cross multiply. So this times this is what? 82x equals oh yeah, calculator. Now you can use calculator. Equals what? This times this is what? So you now divide both sides by what? 82. 30. Where is over? Okay. 39. That's nice. You see, this girl knows she's now speaking very well. My influence. That's nice. Normally she said 39. But now she's speaking very well because of my influence. She said 39, Okay. So we use the same method. Nothing changes. So we draw the two thermometers. The bad and the good one. So This is the bad, and this is the good. Now, according to the question, the bad one records at what lower fixed point. What is the lower fixed point? 8. Upper is what? 90. And then lower, sorry, for the good one, you should have 0 and what? 100. They are now asking us, what is this temperature? Let's call it X, when this one is what? 40. So my lower interval here is 40 minus 8, right? Over 90 minus 8. This is going to be X minus 0 over what? 100 minus 0. So this is 32 over 82 equals X over 100. Cross what? This is going to give me 82X equals 3200. Are we here? And X becomes 3200 over 82. What would that give to me? 39 point. Okay, just approximately what? 39. Are we here? Degrees Celsius. Is that understood? Good. Oh yeah, third one. Simple one, hard one, or do your worst? Simple one, hard one, or do your worst? Look at me in the eye and tell me to do my worst. I should do my worst. I should do my worst. Okay. Okay, don't worry. Let's take it gradually, because obviously you already know what that cost you before. Oh, I'm scared. Oh my God. Like, when my gosh, I'm scared. Oh yeah, take the question. Take, right? Take. Let me have mercy on you. Sha. Right. Are we there? A faulty thermometer records minus 2 degrees C. Minus 2 degrees C at ice point. Minus 2 degrees C at ice point. Minus 2 degrees C at ice point. Are we there? And 98 degrees C at steam point. And 98 degrees C at steam point. And 98 degrees C at steam point. Are we there? What does this thermometer reads? What does this thermometer reads? What does this thermometer read? What does this thermometer read? What does this thermometer read when the actual temperature is 60 degrees Celsius? What does this thermometer read when the actual temperature is 60 degrees Celsius? What does this thermometer read when the actual temperature is 60 degrees Celsius? What does this thermometer read when the actual temperature is 60 degrees Celsius? Okay, so just don't be excited, read the question and then try to solve, okay? Do you have an answer? Okay. Okay. 163. What did you get? 62. Okay. Yes, let's go. More questions. Okay, oh yeah. Let's get the answers together. There is no time. Abambo, are you with me? Let's go. Okay, so I will draw the two of them. Now, the bar thermometer records minus 2 degrees C here, right? And then records what here? 98. 98 degrees C. Then, the normal thermometer is supposed to record what? 0. And what? 100. Okay? Now, what they now ask us? They said, what does this thermometer records? Which thermometer are they referring to? The bad one. So that means that we are looking for this guy up here. But here is how many? 60. Okay? If you know you misplaced it, you either go already. Did you misplace it? You misplaced it. You put 60 here. X here. Either go away. Kedin came 60 here. X here. Ah, God have mercy. You also did like this. Okay, you did it the way I did it here. How did you now do it? 60 here. Please read the question. Some of you, your physics problem is English, not physics. Oh yeah, go do you there back. The answer. No, from that place. What does this word thermometer? Now, who are they referring to? Who are they still referring to? The 41. You know, that is what you learn in English. In English, that is what you learn. If I say Chinaza came to my house and stole my book, then she now went outside and called my neighbor. Who am I still talking about when I use she? Chinaza. English. English. When you don't understand English, how will you understand physics? So the question was, they are still referring to the bar thermometer. So when this thermometer, what does this thermometer records? When the what? When they get actual. When they actual, they said they even mentioned actual. You still went ahead like car will no get break. Oh yeah, let's do this. So I will say x. My small interval here is x minus 2. You know why it is minus? Minus because of this one. Then all over 98 minus 2. Abia? Did somebody do something like this? Who? That's awesome. Yes. Class. Then 60 minus 0 abia? Over 100 minus 0. Minus is what? So this is x plus 2 over 100. Abia? Because 98 minus 2 is 100 equals 60 over 100. Abia? Good. Then 100 can actually cancel 100, or you cross multiply anyhow you want to do that, but both of them can cancel out. Then x plus 2 is equal to 60. So that x becomes 60 minus 2. And x becomes how many? 58 degrees. Did somebody get this? Good. That's good. That's good. At least we have some people that sabi book. Okay? That all people that failed it are those people that are shouting, dear us. Many, and I've not even done my words yet. Yes, please ask your question, Rice. Yeah, still the same thing now. Like, yeah, it's still the same thing because minus will still give you plus. Are we ready? Okay, what's the time? Our time is almost up, so I'm going to give you some assignments that you're going. Okay, let's have one more example before I give assignments. Is that cool? Good. Be fast. I need to go and supervise my students in their exam. Sharp. Are you ready? Are you ready? Oh yeah, let's go upper. Now right. Convert 60 degrees Celsius to Fahrenheit. Convert 60 degrees Celsius to Fahrenheit. Convert 60 degrees Celsius to Guinea Fahrenheit? That's the question. Okay, now there are formulas. But we don't need the formula to solve it. In fact, this method is how the formula came about. Okay, there is a formula that you can use to convert Celsius to Fahrenheit. In fact, I'll write it down for you for free. Okay, if I want to convert a temperature from Celsius to Fahrenheit, look at the formula. Fahrenheit temperature is equal to 1.8 Celsius temperature plus 32. Okay, Fahrenheit temperature is equal to 1.8 Celsius temperature plus 32. So meaning that if I was asked to convert a temperature in Celsius to Fahrenheit, I can simply use this formula and get my answer. Let's do that. F is equal to 1.8 times, what is the Celsius temperature? 60. Then plus 32. Now, what is 1.8 times 60? Help me out. Sharp now. 1.8 times 60. 108 plus 32. What would that give me? 140 degrees Fahrenheit. Okay? So, it is 140 degrees Fahrenheit. Now, but we are not going to use the formula. Let me show you how to do it. Because sometimes, let me tell you one thing about formulas. Is that it might skip your mind. Are you with me? It might skip your mind. But if you know the principles, you will be able to answer it. Okay? Now, if they ask me to convert from Celsius to Fahrenheit, draw the two thermometers. 1 Celsius, 1 Fahrenheit. Now, for the Celsius scale, eba yabu 0 here. Eba yabu gene. For the Fahrenheit, eba yabu gene 32. It's in your note, oh? And then here's how many? 212. Now, what temperature are they asking us to convert? 60. So we are asked to convert 60 degrees Celsius to Fahrenheit. I don't know the value, so call it F. This is 60 degrees Celsius, okay? And we are converting to Fahrenheit. I don't know the value. Making sense? Then use our normal formula. Small interval over large interval. Small interval here, yeah, 60 minus 0 over 100 minus 0 equals F minus 32 over again minus 32. Okay, oh yeah, let's move on. This will give me how many? 60 over 100 equals F minus 32 over how many? 180. Up here? 0 can cancel 1 0 here. Up here? Now we can even go and cancel this 0 and then cross what now? Multiply. 6 times 18. Sharp, 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 sharp. 6, okay, let's do like this. F minus 32 is equal to 6 times 18 is what? 108. F is equal to 108 plus 32. And that will still give us what now? 140 degrees Fahrenheit. Are you seeing it now? Now you see that the formula is shorter. Where's your formula is shorter? Yes, but why am I showing you this? In case you go to exam and you forget the formula. Is that making sense now? And then if you forget the formula, does that mean you should not skip that question? No. You can come back later and use this method and solve it. It still works. Is that okay? Good. Oh yeah. Copy it and take your assignments. Or in fact, take your assignment. Don't worry, the board is still there. You copy it when I'm gone. Is that okay? Take your assignment. Just give the space and take your assignment. Number one. A faulty thermometer records 6 degrees C at steam point. Sorry, at ice point. A faulty thermometer records 6 degrees C at what? At ice point. Shall I be mad? Yeah. It's Yahoo. At here. I didn't say so. Eh? That was what I said. Please, we are online. Okay. I didn't say that. The Lord, did I say anything like that? You see? Yes. My lawyer is here to defend me. Okay. At getting ice point. Are we there? And 92 degrees C at steam points. And 92 degrees C at steam points. And 92 degrees C at what? Steam points. First step. Determine the actual reading. Determine the actual reading when this thermometer records 28 degrees C. When this thermometer records 28 degrees C. When this thermometer records 28 degrees C. Imegia? Good. Now let's move on. Number two. Are you there? A resistance thermometer has a resistance of 5 ohms at ice point. A resistance thermometer has a resistance of what? 5 ohms at ice point. 5 ohms. Ohms. Now you don't hear of ohms before? This is the symbol, okay? This is the symbol. Has a resistance of 5 ohms at ice point, and 8 ohms at steam 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 point. Full stop. Calculate the resistance at 45 degrees Celsius. Calculate the resistance at what? 45 degrees Celsius. Calculate the resistance at 45 degrees Celsius. It is very simple. Draw the two thermometers, the resistance one and the Celsius one, and you will get your answer. Is that okay? Number 3, right? Number 3. Sharp. Are you there? Good. The height of mercury at ice points is 100 millimeters. Is 100 millimeters. Is 100 millimeters. Is 100 millimeters. At steam point it is 180 millimeters. At steam point it is 180 millimeters. Are we there? Full stop. Determine the length of mercury. Determine the length of mercury at 60 degrees C. At 60 degrees C. At what? 60 degrees C. Then the last question, number 4. You know I love you so much. Last question, number 4. Are you there? Convert 100 degrees Fahrenheit to Kelvin. Convert 100 degrees Fahrenheit to Kelvin. I hope you know what to do there. Good. Convert 100 degrees Fahrenheit to Kelvin. Now I'm expecting you to answer these questions. Okay? Answer them before the next class. Are you with me? Good. I will see you when I see you.